Hi, Neil. Can you please introduce yourself and tell me what you do at 4D Technology?
My name is Neil Brock, and I am the technology director with 4D Technology. We design and manufacture laser metrology systems. These systems are used for testing primarily large optics, and these large optics are used in Earth-based, space-based telescopes, space probes, spy satellites, Google Earth imagery, all those kinds of things. And what we do is our systems will measure these surfaces so that they're perfect, so they can create perfect images. And so our customers are all the aerospace companies that are involved with those kinds of things. Some are here in Tucson, Raytheon and the Boeings and every one of those aerospace companies that are in the U.S. as well as foreign companies, all the national labs, NASA, those kinds of things. Those are our primary customers. And the big programs we've been involved with over the last few years are things like the James Webb Space Telescope, which hopefully will launch later this year. Keep your fingers crossed.
Right, I forgot about that. Yeah.
Yeah, it's way behind schedule, but there's a lot to it. It's one of the most sophisticated scientific instruments ever made, and every aspect of that instrument, all of the optics, the primary mirror, the secondary, tertiary, the IR camera, the structure that holds all the mirror segments together, every one of those things have been tested with 4D metrology equipment. So we're very proud of. And I think here in Tucson, people are aware of the Large Binocular Telescope on Mount Graham. Well, they have a couple of our interferometers built into the telescope.
Oh, very cool.
Yeah. So there's also these new telescopes. The Mirror Lab is making the Giant Magellan Telescope, GMT, and they're using our interferometers to make sure those mirrors are perfect. And then there's two other ones that are being built right now as well, mega telescopes. These are billion-dollar telescopes. There's the 30-meter telescope. That's an international project. And then the European Extremely Large Telescope. Those are massive telescopes that'll be the biggest ever made. So a lot of things to look forward to, and I'm very happy to be involved with those projects.
Great. So that actually covers kind of my second question, which was what does 4D do and what kind of markets? But so I know, that it's, I guess it sounds like for each of these, there's basically a custom instrument that's designed for each program. Is that every single instrument that 4D makes is custom? You have, I believe, some that are, more off the shelf. Can you tell us a bit about that?
Sure. I mean, that's sort of the challenge. I mean, we do make custom interferometer systems. Sometimes it's the only way, and we'd rather make several things over and over again. And we do primarily. We have several products that we sell in the hundreds even. But there's always somebody who comes to us and says, "Hey, can you make something that can do this?" And we say, "Well, we can, but it's going to be really pricey." We try to scare them off, and sometimes we're successful, sometimes we're not. But either way, we're happy to make these things because it's something we're very proud of. And so there is a mix there of and when I say custom, we don't like to ever do a one-off. Custom is really something that's less than 10 units that's what we call custom.
Okay. That's good to know. Yeah, I wasn't sure, so I figured I'd ask because these are all very different projects that you're talking about, from the GMT to the space telescope. Obviously ground versus space is wildly different in terms of imaging. So I wasn't sure if the testing was done similarly.
Right. Now, the primary reason that people come to us is that when you're testing really large things like that, they want to measure these surfaces down to sometimes sub-nanometer. And when you're measuring something large at sub-nanometer, you have to hold it steady, and everything moves. Nothing is ever perfectly stable, and things move, on the order of microns, which is millions of times more than a nanometer, or 1,000 times more than a nanometer. So it's really difficult to get quantitative, precise measurements down at the nanometer level unless you use our technology. And that's really that's the thing that really our company has grown on, is that we can make nanometer resolution measurements despite there being lots of vibration.
Very cool. Very cool. Thank you. I appreciate all that explanation. I think that'll be really useful.
Good.
So I'm gonna kind of divert us a little bit and ask, what brought you and 4D both separately to Tucson? What was the draw of Tucson?
Well, so I'm actually one of the founders of 4D, and we started the company in Irvine, California. And we quickly burned through our venture capital funding, and we needed additional investors, and we got so lucky. Turns out we attracted a professor, John Hayes, from the U of A, and then there was someone named Jim Wyant, who I know most people in Tucson know. He was the future dean of the Optical Science College, and I think probably most people know that the college is named after him today. Well, he was one of our investors. He was the chairman of our board for basically almost 20 years.
Oh, wow.
And so it was very fortunate. And he brought us to Tucson because he knew it had a good photonics industrial base to support us. But more importantly, it had the expertise. With the Optical Science College there, we had a great source of top-notch talent. And but not just optical science. We've hired so many U of A graduates. It's been a very good thing to us. So that's what brought us to Tucson. And we didn't appreciate what a great opportunity it was. I remember dreading coming out to the desert. I know, believe it or not, but we were coming from Southern California, right? But it didn't take long before we fell in love with Tucson, and definitely appreciated the great photonics environment that we have here in Tucson.
That's great. I mean, we've heard a lot of stories about, connections with the U of A have brought people out here, or just having the industry here is a big draw. And so I think it's like its own self-fulfilling prophecy,
Yes.
because the industry is here, it's drawing more industry out here. And the desert also seems to really latch on to people. Everyone loves the sunshine. That's what we've heard.
Yeah.
So that's great. I've heard, over the years, the story of 4D, and obviously Jim's involvement, and his involvement. We've heard his name a bunch of times, throughout all these, just all of the work he's done in really lifting up the whole optics community. So it's been really great. So I'm going to ask my last question, and then if there's anything else, we can cover that. So how do you see the work that you're doing, that 4D does, affecting the future? Now, this could be the future of the Tucson economy, the Tucson community. It could be our community at large, or it could be just like broad strokes, how we as humans interact with the world.
Well, that's pretty deep.
It's meant to be open-ended, so.
Well, that's great. So, 4D has always endeavored to be a great company where people love to work. And James Millard and I, the original founders, we had worked we worked somewhere together that we didn't. There were a lot of examples of how not to run a company that we got tired of dealing with, and so we that was the primary motivation, really. And I think we've created that, and I think being a part of the Tucson community, not just the optics community, but the general public at large, I think that we have a responsibility to be involved with STEM programs and and other programs. We've had high school kids and middle school kids come through so they can get an idea of what we do, because it is a very cool thing when James Webb Space Telescope starts creating these incredible images that are going to blow everyone's minds. Yeah, we had a part of that, and that's something to be proud of. And all the engineers and technicians and all the other great people we have here, it's a team effort, and they've all had a hand in that, and that's something they can all be proud of. And I think hopefully it's something that Tucson can be proud of, because the university had played a major role in James Webb Space Telescope. Jim Wyant was on their advisory board for many years, so definitely it'll be a moment for Tucson to be very proud, I think. So where are we going in the future? So we sold the company 2.5 years ago to a semiconductor metrology company called Nanometrics. And then shortly thereafter, we merged with another company called Rudolph Technologies, another semiconductor metrology company. And now we're called Onto. 4D Technology is a business unit of Onto. And they're very excited about our technology and what it can offer in semiconductor. We have been working on products for the semiconductor fabs, and then the real key for us is to adapt this technology that was used to make the most powerful telescopes in the world, adapt it for other mainstream industrial applications. One of our latest products is a handheld tool. It's a 3D measurement tool, handheld tool that can measure jet engine turbine blades. And I think everyone can agree that the jet engines can never be too reliable. So
yes.
we believe that our technology can really help that industry. And we've been selling quite a few to airlines and all the jet engine manufacturers. That same technology can be applied in the automotive and many other industries. And so our goal is to get this precise 3D metrology equipment that we've developed over the years, get it into more mainstream applications so we can grow the business.
That's great. That was both broad strokes and Tucson. That was fantastic.
Good.
I think, obviously we all kind of, Hubble changed how we looked at, the universe around us. And I think that James Webb is going to do the same. And I love the fact that, it's, as you say, it's something that Tucson can be proud of, because it was really a group effort. I mean, between the metrology and the actual, getting it to happen and the making it and designing it, I think it's really a testament to the power of collaboration. And Tucson plays a big role in that. And so I think that's a really great reminder.
Yeah, good story we've told for years. You might recall when the Hubble telescope launched and it had first light. First light is that term they use to describe when they first get light onto the camera and they can see what they see, and it had blurred vision. And it took them quite a while to figure it out. And what they found out was there was a mistake made when they were testing it. And so it's something we're proud of. We're like, if they would have had 4D technology back then, because that was all built before and launched before 4D was even a company. But if we were around, we could have prevented that. But
well, now you're part of the next generation, the even bigger, the even better telescope, which is going to be fantastic.
It will be. There's no
That's
doubt.
awesome. Thank you. I just that was all my questions. Was there anything else you want to share, whether it be a piece of advice or more about interferometry, because interferometry is so cool? Is there anything else that you would like to add?
Yeah, for the layman that wonders what is interferometry, and My wife couldn't even explain it after all these years. And I've been working in interferometry for my entire career. That's a long time. But interferometry is using light waves to measure things, just like you use a ruler to measure an object. You know, if your ruler is a wavelength of light, which is really, you know, if you squeeze your fingers tightly, that's about how long a wavelength of light is. It's extremely small, and I mean, it's on this order, on the order of a nanometer. So that's a billionth of a meter, 1 billionth of a meter, which is just so tiny. But that's our world. That's our 3D world is the nanometer range, and we measure things in that area. We use the light waves to measure things, and everything, every precision surface that's out there needs to be measured, and it could be pistons or the cylinders in your automotive engine, and your the jet engine turbine blades. I mean, your glasses, the optics that are in the cameras that are imaging us. All those are tested with interferometers, and not necessarily 4D interferometers, but they're all tested with interferometers. It's a really important technology. It goes, all technologies go hand in hand with your ability to measure things, and that's what we do.
That's fantastic. Thank you so much.
Good.
We really appreciate your time.